In this video, we're going to be talking about on-click handlers and Java inner classes, which is an interesting feature that you don't see in really any other languages that I'm aware of, that we will definitely need to get a good handle on because we'll be using them quite frequently throughout this course. There's a couple caveats about them that we are definitely going to want to discuss. So what I'm going to go ahead and do is I'll just come over here to our Android Studio splash screen and I'll say start a new Android Studio project. And here, what I'm going to do is I'm just going to call it Views Part 2. So I'm going to say Views Part 2. And since my company domain has already been inserted, I don't have to worry about filling that in. Next up, I'm going to hit Next. And let's just go ahead and keep those defaults right there. And we'll start off with a blank activity. And we'll keep that activity called main activity. I'm not too worried about implementing or writing an activity from scratch here in this particular video because we're mostly going to be focused here on our layout file, well, and the activity class, but we're going to nuke a bunch of the stuff out of the activity class, just so we don't have to deal with opening up the manifest for this particular example. Now, there's not going to be a whole lot of code in this video. Hopefully, we won't take too long because there's really not a whole lot of things to discuss. It's just really important that we understand some caveats about working with Java in this way. Okay, so what we see here is we have our layout, activity main.xml layout, and we also, under our views part 2 package, we have our main activity class. So what I'm going to do here is, to start off, I'm just going to remove all the things that we don't need to worry about. So maybe clear up those empty lines a little bit. And then I'm going to remove all of the methods other than onCreate. So I'm going to just select all this stuff. All those other methods are completely irrelevant to what we want to discuss in this video. And I want to only have in our main activity the code that's required for what we're discussing. So let's hop back over to activity main and let's talk about buttons. So we already saw an example of a button in the first video, and the way that we handled its on-click event is that we wrote in an attribute called Android:onClick, and what that attribute did is it wired up the click event handler for that particular view into our activity by matching it up with a method name that we wrote on our activity. Well, for the rest of the series, and for this video, we're not going to be doing that. Because I am not really a big fan of wiring up on-click handlers that way. I find that I don't really want the XML file to have intricate knowledge of what is in the activity. I feel that breaks the separation of concerns just a little bit too much for my comfort. So instead, what I'm going to do is I'm going to present an alternative way to effectively accomplish the same thing. And in this case, what is the thing we're trying to accomplish? Well, we're just wanting to wire up some code to have happen when we press, tap, or click on a button. So in order to do that, the first thing we're going to need to do is create a button inside of our layout. Now, you'll see our layout is not using a linear layout at this moment. It's using a relative layout. I'm going to go ahead, just so we can have a video dedicated to relative layouts, I'm going to enter in a new line right there, and then I'm going to just replace the word linear layout with, or relative layout with linear layout. And again, I have to keep on pointing this out because the autocomplete is so important to be able to get used to working with IntelliJ's autocomplete. It is going to be case sensitive, so you'll want to start off with a capital L. Now, fortunately, linear layout happens to be at the top, so we can just hit enter. Of course, changing the opening tag is going to necessitate that we change the corresponding closing tag. So make sure you go all the way here to the bottom and replace relative layout with linear layout. Now, the last thing that we need to worry about when changing between a relative layout to a linear layout is our linear layout has a property that is very important that we set, and that is the orientation of the linear layout. Is it going vertical or horizontal? We talked about that in the last video. So all I'm going to do here is, ignoring all the rest of those attributes, which are relevant, I'm going to add a new attribute into our linear layout called orientation, and I get there just by typing OR and hitting enter, and then I'm going to select vertical, so that our views will stack underneath it. So once I've done that, let's go ahead and create a button underneath the text view. So I'm going to open up a capital B, and we get button, and I'm going to hit enter. Now for this button, I'm going to have its layout width and its layout height wrap content, which means it's going to be as tall and wide as it needs to be to contain the text that I'm going to insert into it. You'll notice by default it has this minimum height right there, but that's going to be determined by the particular style of the button. Now the style of the button, what you're seeing right there, because this is the first time we actually are seeing some visual elements, some visual style, visual theming for our views, you'll notice that it's already filled in with something, and that something actually looks different than what we had in our Android Quick Start video. And that's because when we create a new project from Android Studio, we default to a theme called App Compat. So again, we'll have an entire video on App Compat very soon here, but for now, that is why this button is going to look a little different. In fact, it's going to look as close as it can right now to the material design that was introduced in Android 5. Anyway, so there's a couple more properties I want to put on a button. Not surprisingly, our button is going to have a text property. In fact, the button class itself, the button view, inherits from text view. We can actually see that ourselves by control-clicking on button and seeing the actual source code of the button class, and we see it's actually pretty not that interesting, and it's more or less just a text view. A button is really just a text view. So you might be thinking, well, where do the hover states come in? Where does all that fun stuff come in? That has to do with the style that's being applied to the button. So functionally, they are very, very, very equivalent. So we're going to use the text property, which is inherited from the text view property, and which will not surprisingly provide some text into our button. So I'm just going to say, click me. And you see when I do that, in our preview over here, that fills in. And so we see that our button now says, click me, underneath our text view, which says hello world. It is really interesting to think that these are effectively the exact same classes. But anyway, so what we would have done in the last video is we would have given it an on-click handler, assuming that we want this button to do something when we press it, which is going to be very common with buttons. But in this case, what I'm going to do is I'm going to provide it with an ID. So I'm going to type in the word ID and hit enter, and then I'm going to do @+ID/, and then I'm going to say activity main button. So again, what are we doing here? We're creating a new resource. We know we were creating a resource because we had the @+ syntax. What kind of resource are we creating? An ID. What is the ID of that ID? Activity main button. Again, this will allow us to reference this view from within our Java source code. Without the ID, it would be very difficult to find the button, find a reference to the button. Now, the last thing I'm going to do here is I will go ahead and break this down just a little bit. I'm just changing the. I don't really like having attributes on multiple attributes on one line. It kind of irritates me. But what I am going to do over here on this text view is I'm also going to give this text view an ID. So I'm going to say ID enter @+ID/, and then I'm going to say activity main text view. You'll notice this is going to be my naming convention here. Whenever I have more than two words in the name of the control that I want, I'm going to camel case them. And then you see the prefix is always going to be the name of the layout file. And again, like I said before, this is to prevent conflicts with our IDs and different layouts. Normally that actually wouldn't matter because it only matters that IDs are unique within that particular view hierarchy, meaning you could easily get away with reusing IDs in multiple layouts if you wanted to. And sometimes you should, but that only comes into play when we include other layouts, which we'll do later. But for most of the time, I really like having unique IDs for clarity's sake. And if I ever have a circumstance where I start injecting multiple IDs in the same view hierarchy, I just like, having things be namespaced properly. So we have our button, we have our text view, and they both have IDs, meaning we can reference them from our main activity. So let's go ahead and do that. Let's jump back into the main activity, and let's talk about one of the most common patterns we're going to have when working with activities that have views, that have references to those views from those activities. So basically, working with views that we need to manipulate from within our activity. You'll see this pattern used throughout the course. The pattern is going to be, inside of our class, we'll create private fields that correspond to those particular views. So in this case, we have a text view and a button. So I'm going to say private text view. Now, capital T, blah, 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 and then I'm going to select in the autocomplete, and I'm going to hit enter. Again, we do that so the import statement up here appears at the top, import Android widget text view. Otherwise, it wouldn't have, and you guys would have had to type that in manually. I'll show you an alternative to that actually in a second. So I'm going to say private text view, and then I'm going to name this text view. Really uninspired name, I know, but still. Okay, then I'm going to say private button. Now, what happens? So what would happen if you just typed in button, but you didn't hit enter there, and you just said button? So what would happen there if you were typing too quickly, you forgot to use the autocomplete text box correctly, but you still don't want to go all the way up to the top of the file and say import Android widget button? Well, the answer is right in front of you. Just like ReSharper, IntelliJ will allow us to import the appropriate package by hitting Alt-Enter. And you see that because this is the most pressing issue in the entire file, this becomes the default issue, meaning no matter where my keyboard cursor is in the file, I can hit Alt-Enter. And by hitting Alt-Enter, we get an import for Android widget button. I still find it much faster to use the autocomplete window correctly and hitting enter on it. Anyway, now that we have our two local variables that are going to correspond to our views, how do we acquire them? Well, remember the onCreate method. The onCreate method gets fired when the activity gets created, which is why it's called onCreate. And the first thing we're always going to do in our onCreate method is we're going to call through to our superclass. So we're going to call our superclass's implementation of onCreate so it can do all its Android-y things. In fact, we will get an error if we don't do this, so always do that. Now, the second thing we're typically going to do on almost all of our activities is set a content view. Now, what does the set a content view do? Well, we talked about it in the last video. Basically, all it does is it gets a reference to a layout file and inflates that layout file and sets it into our content view, our root view. See, we already have a root view in our activity, and we want to go ahead and add a bunch of children to it based on the contents of this layout file. So now that we've done that, that means our view hierarchy has been inflated. It's been constructed. So as of now, where my keyboard cursor is, this view is being displayed to the user, and these three objects are being instantiated, or have been instantiated. Our linear layout, our text view, and our button. So now at this point, what we want to do is we want to extract these views. We want to get a reference to them. Now, the way in which we do that is going to be with the findViewById method. So, let's say on this text view, I want to get a reference to the text view. I'm going to say text view equals findView. Now, this is going to error out, and I'll show you guys why. FindViewById, and then I pass in an ID resource. Now, remember, we created an ID resource for this text view. It's activity main text view. So, all I have to do is say r.id.activity main text view, and then close it. Now, we will get an error, and that is because the findViewById method, if you look at its signature, it is public view findViewById int ID. It returns a view. It returns a base class. It doesn't return the specific text view. And there is no generic overload for findViewById. So, effectively, what we're forced to do is we're forced to cast it. So I'm going to cast this to a text view. And by casting it to a text view, I will, well, have my text view assigned to the text view field without having it throw an error, because a text view is a more derived class than view. Remember, all views inherit from the view class, including view groups. Now let's do our button. So our button's going to be pretty much the same thing. We're going to have button, findViewById, r.id, activity main button. Okay, so we haven't yet discussed what we want the button to do. Well, this is just going to be a really quick basic example. It's not going to be particularly interesting, but let's go ahead and see if I can shove one more Java-y thing discussion into this video in addition to what we're going to be doing with inner classes. So what I'm going to have happen is every time I press the button, I want a number to increment on this text view. I want this text view to say, you know, clicked once, clicked twice, clicked 3 times, and so on. So what I'm going to do here is in mainActivity.java, I'm going to add a new private variable. And it's going to be private int count, or click count. That's a better thing there. So we do private int click count right there. And what I want to do is I want this to increment every time, and then I want it to be assigned to a particular a string on the text view. So now we have basically everything in place except for the actual onClick handler. Now the way that we're going to be doing this is, if I do button dot, I'll get an autocomplete window for my button. Now there's this method here called setOnClickListener. We also have a corresponding setOnLongClickListener, which does the same thing, except it's when you press and hold the view instead of just tap it. Now the setOnClickListener takes in a interface, or rather the implementation of an interface, the onClickListener interface. Now it's interesting to note that in Java it is not customary to prefix your interfaces with the I letter. So in C# you would be expected to, any interface you write, you prefix it with I. It doesn't change anything functionally, it's just a language convention. In Java, that's not the case. I am not a big fan of that lack of a prefix, but what can you do? Anyway, so we have a setOnClickListener. We need to pass in an implementation of an interface. So how do we do that? Well, there's going to be 3 ways in which we would be able to accomplish this. We could accomplish this with a inner class. We could accomplish this with a anonymous class, or we can accomplish this with having mainActivity implement the onClickListener interface. Now the easiest one, or at least the most conceptually similar to other languages implementation, is going to be having the mainActivity implement the onClickListener. So let's go ahead and do this one first. What I'm going to do is I'm going to say setOnClickListener, and then I'm going to type in this. And of course, this is going to reference the current activity. Then, up here at the top, now you'll see we have an error here. And now the error should be pretty self-evident. We're saying we want to pass in a implementation of onClickListener, but the object we're passing in, the main activity, doesn't implement onClickListener. So let's go ahead and make it do that. So what up here, I have public class mainActivity extends action bar activity. Like many other languages, in Java, you are only allowed to extend from a single superclass, a single base class, but you can implement as many interfaces. But unlike many languages, you do not do that with a comma. Instead, you just type in the word implements, and then after implements, you type in the interfaces that you wish to, implement. In this case, we want onClickListener. Now, this is an interesting thing about the autocomplete dialog. OnClickListener is a very common, you see it's a very common little pattern of words that they use in the Android framework. And what you're looking at are different interfaces that are nested inside of different classes. So that's interesting because you see that IntelliJ is intelligently searching not only what we have visible to us as a top-level interface, but it's also searching for things that are in other classes, nested interfaces. And in this case, the onClickListener that we want is android.view.view. So we're going to click on that. And so what is that going to do? Well, it did 2 things. It imported android.view.view, and it also specified view.onClickListener for the interface that we are implementing. Now, this interface requires us to implement one method, and that one method is not surprisingly called onClick. So up here I'm going to say public void onClick view. And the contract is now complete. So basically, a recap of interface and interface just requires that you specify the methods that it specifies. So, for example, because onClickListener necessitates that we implement a method called onClick that accepts a view object, we have to, implement a method called onClick that accepts a view object. And now that we've done that, the contract is complete, and we've implemented the interface. Because we've now implemented the interface, all the errors go away, including the one that previously was on this line. So in this onClick method, what we can do is we can implement the logic that we want to have happen when we click the button. Now, somebody paying very close attention might be asking, well, what if we have multiple buttons on this page and we want to be able to handle different click events depending on which button was clicked? So you see that every time we say set onClick listener and we pass in this, we still only get one onClick method that all of the buttons would be routed to, assuming that we've set their onClick listener to this. Well, the easiest way to do this is to compare the view object that's passed into the onClick method with what we want to have happen. So in this case, I can say if view equals button, then I now know that the thing that was clicked was my button object, my button field, which I have set up here. An alternative way to handle this, if you don't want to keep private fields that reference your objects laying around, instead you could say if view dot get ID equals r.id.activity main button. Now both statements would be equivalent because in this case that is the ID of the view that we're wanting to handle. But either way would work just fine. So now we can go ahead and we can implement some logic. So what I'm going to do is I'm going to say click count plus plus, first of all, is to increment our click count. And then I'm going to set some text on text view. So I'm going to say text view, set text. So the set text method is going to want a char sequence, a char array, or a string resource. If you recall, string resources are how we deal with localization inside of Android. In this case, the overload that we're going to be using is going to be char sequence, since the string type is an inheritor of that base type. And of course, by inheritor, I mean implementer. So we're going to say clicked, and then we're going to concatenate on click count, which is the variable that we just incremented. So let's go ahead and run this code, because as of now, it should go ahead and do what we want it to. So I'm going to fire up Getting Motion here. And maybe pause the video while this is launching. Oh, there's a new version. I'm going to go ahead and download the new version as well. So I'll be right back. And now that update has gone through. For you guys who are following along, it'll just require that you update your Getting Motion your actual Getting Motion installation, and then when you try to launch your device, it'll ask you to update your device, and it'll go through a quick update process, and it has done that. I just read through the release notes, and there's a couple of really nice bug fixes that they put in, including one really annoying one where there was this issue with the web view. But either way, I would recommend you guys go ahead and get that updated. But yeah, so let's go ahead and move that out of the way so we can look at our emulator, or our virtual device. Now I'm going to come up here to run. I'm going to say run app. And I'm going to go ahead and wait 25.7 million years for Java to compile stuff. And then I'll say use same device for future launches, which is typically what I'm going to be doing throughout this series. And now we have a device, and it is running. So we see our action bar thing, and we see our hello world, and we see click me. So if we hit click me, we get clicked and a bunch of other stuff. So that's really cool. Or our click handler is indeed working. Shouldn't come as any surprise because this looks pretty straightforward, right? We have a implementation of this interface, and we set the onClick listener, and we have our onClick method. I will go ahead and, when I say clicked on click count, I do want to go ahead and say plus time plus click count is not equal 1 s. There we go. Oh, are you kidding me? What are you? Oh, that's probably why. Anyway, so now that we have that, let's go ahead and talk about an alternative way that we can handle this. So if you're familiar with C#, you may be familiar with the concept of nested classes. Well, Java supports nested classes, but it also supports what are called inner classes. So what that means is we can have a class inside of our other class, and it's nested inside. But when I refer to them in Java, I'm going to call them inner classes for a very surprising bit of behavior that they have. So let's go ahead and define it. What I'm going to do here is all the way at the bottom of my file, I'm going to say private class, and I'm going to call this button click handler, and I'm going to have it implement view.onClickListener. Okay, so then I'll have a public void onClick with a view, and I'm not going to do the thing I did on the parent class's view getID equals this, because this is going to be a click handler that we'll be able to instantiate on a per view basis. So there's really it's not necessary in this particular instance to check to see what view was actually clicked. So instead I'm just going to repeat the behavior that we have already. And I'm going to start that off by just typing in click count plus plus. Now immediately people who aren't familiar with Java should be like, what is going on there? Because if you think about it, what are we doing here? We are referencing an instance variable of the parent class as if it were an instance variable or a local variable of our nested class. Well, that's why they're called inner classes in Java. Basically what happens is when we instantiate this class, we either need to instantiate it only from within the context of main activity, or if we instantiate it elsewhere, we have to instantiate it with a reference to a particular instance of main activity. Basically, this class, when it gets instantiated, is going to get behind the scenes, a instance variable that's going to point to the main activity, the parent class that instantiated it. Meaning we'll be able to reference all of our private fields as if they were private fields of our nested class. So what if you don't want that behavior? What if there are certain instances where you don't want that to happen? Because right now we have potentially or could potentially introduce a memory leak that would be very difficult to track down. What do I mean by memory leak here? We're working in a managed language. It's not like we have to deal with manual allocation and deallocation of memory. Well, what I mean by memory leak is there might be a certain circumstance where we have our activity and our activity gets destroyed for whatever reason. It goes out of the screen, it closes the app, whatever. But an object such as this one that was instantiated from an inner class still stays alive because he's referenced by somebody. He's in the static collection somewhere. You know, if you've dealt with managed languages very often, you'll know that if you leave your objects around in a collection that's static, they won't get garbage collected at all. So what we have to do is we have to make sure that we don't let this class leak, or objects of this type leak out into anywhere that is longer lived than the activity, because then the garbage collector won't be able to collect on the activity. It won't be able to deallocate all the activity's memory, because this object, any object instantiated from this class, is going to have a reference to a main activity object. And in Android, activities are relatively expensive as far as memory is concerned. So just a quick note on that. What if we didn't want that behavior? What if we wanted this class to behave as if it were a class defined in a separate file? Well, that's when we introduce the static keyword. So watch what happens when I say private static class. Now you notice I don't get an error anywhere else except for right here, where it says non-static field click count cannot be referenced from a static context. All this means is we've now made this class no longer contain an automatic reference to our main activity class. So by giving it a static class, this class now behaves as if it were defined in a separate file. But of course, without that static modifier there, we get the behavior of being able to reference local variables. Which means not only will we be able to reference click count, but we'll also be able to do textView.setText. So we'll be able to say clicked, I want a space there, click count plus time plus click count does not equal 1, s empty string. Okay, so we've now created our private class. So now that we've done that, what I can do is I can go ahead and remove all of the code that was previously there to support this click event. So I'm going to remove our onClick method from main activity. I'm also going to make main activity no longer implement the view onClick listener. So now it no longer implements that. So now what do we do? So now we get an error right here on our set onClick listener. So not surprisingly, what we do is we say new button click handler. So yeah, now if we, we'll instantiate a new instance of this class. We'll set it as the click handler, our click listener, and we'll get the same behavior as we did before. I can prove it by coming up here, hitting run, saying run app, and then waiting for this app to compile and deploy. And now I can say click me. And we get the exact same behavior. One more quick note about this. Just as another really interesting weird bit of syntax in Java. Now, it's implied with the syntax we have here, but an alternative way I could do this, which would make it more obvious that this button click handler is going to carry a reference to our main activity, is I can instead do this dot new button click handler. So this dot and then the keyword new followed by the class. This makes it a little bit more obvious that this inner class is going to carry around a reference to our main activity wherever it goes. However, I really think this syntax is ugly, and instead I just suggest that people get used to the fact that inner classes, unless declared static, are always going to carry around a reference to the class that instantiated it, the parent class that instantiated it. Okay, so we have gone about 3 ways so far to do click handlers. We've done the onClick attribute in XML. We have done a inner class, and we have done a implementation of the interface on our parent class. So what about the last way? Well, let's go ahead and I'm going to go ahead and nuke this class, this button click handler, because there's one more way, and it might blow everyone's minds that you can actually do this, but you can. Let's instantiate an interface. So I'm going to say new onClick listener. Now this is the keystrokes I'm typing is significant, so you guys get the same autocomplete behavior as I do. Capital O-N, which right now it'll auto-select onClick listener because it makes sense, because the argument we're passing in requires it to be of that type. Now I'm going to hit enter. So what is going on here? Well, what's going on here is we're instantiating a anonymous class, an anonymous inner class. So it's very similar to the class that we just created, which is just a normal inner class on our main activity, a named inner class on our main activity. But instead right here is we're actually creating a new class and a new instantiation of that new class, but we're doing so inside of the body of a method. So inside of this class, what we can do is we can do the exact same thing we did before. I can say click count plus plus, and I can say text view dot set text clicked. It's like the 3rd time I'm typing this, isn't it? Clicked. Oh, I can't type anymore. Click count time. Count does not equal 1. Okay. So we get the exact same behavior, and I can go ahead and hit run. And after a couple seconds, we will get the same behavior as we did before. Not terribly interesting, except for the fact that we instantiated an interface. Well, not really. What's going on here is that the Java compilers actually allows us to both define, or declare, define, and instantiate a class at the same time. And it allows us to override methods on the class or the interface that we are basing that off of. So in this case, we're saying we want a new class. We're creating a new class and a new instantiation of the class at the same time in the same line of code. And we use this syntax to do it. In fact, we can do this for any class. We can instantiate a class and override particular members of that class and then have that be turned into an object when that line of code runs. So, yeah. So, interesting note, I guess. So, yeah, we can go ahead and just create a new onClick listener, and then we override its only member onClick. This is basically going to be the closest you're going to get to using or having lambdas in Java 7. So, you'll see me do this fairly frequently to handle quite a few different use cases. I'm not too big of a fan of the syntax. I think it's a little heavyweight, and I'm not a big fan of the amount of indentation it adds to my code, especially once you get 2 or 3 nested classes deep. In that case, you should seriously consider refactoring. Now, this syntax has one interesting limitation that's important to understand. What if instead of having these in local fields, see how text view is a local field, and I have access to it because it's a local field because this is an inner class, just like the other inner class we had access to that field? What if it wasn't a field? What if it was just only a local variable in the scope of the method in which this class was both defined and instantiated. Well, we can go ahead and test that out. What I'm going to do here is I'm going to delete these two lines up here. I'm going to delete the two field definitions, text view and button, so that we can declare them instead as local variables. So I'm going to give them their types here. Now we're going to see an interesting error here. So now these are local variables, and they're within the scope of this anonymous inner class, but notice how we get an error right here. The error says variable text views accessed from within inner class needs to be declared final. So basically what that's saying is that any local variable that is within scope of an anonymous inner class, or local parameter for that matter, has to be declared final. Once I declare it final, we don't get an error. Now what is final and why do we need to declare it like that? Well, final, you see final quite a bit in Java, in fact. In this context, final is kind of like read-only in C#. This text view cannot be reassigned to any other variable. Like, let's say, for example, I were to say text view equals null. Now you'll notice that we'll get an error. Cannot assign a value to variable text view, to final variable text view. So, yeah, there's really no equivalent for a local read-only variable in C#. But it has the exact same behavior as if we were to declare a local field as read-only. It's the value simply cannot be reassigned. Well, why is that important? I think it's important from a... if you guys have dealt with languages that have lambdas that allow hoisting, it becomes fairly evident why the designers of Java may have chosen to enforce this. Because let's say I do assign text view to null later down the road, and then this code runs. Because remember, this code isn't going to run when this method finishes. It's going to run whenever the button is clicked. And what if I set text view to null somewhere down the road? Well, then now sometimes this code may work and sometimes this code may not work. And it could introduce lots of bugs. That's not to say that there's like some limitation where you can't be able to reassign things theoretically. It's just to say that that the Java designers intended this to prevent very common bugs that may have been introduced by them allowing the existence of local inner anonymous classes. Anonymous inner classes. Words and words and words and stuff. So basically the moral of the story is if you have an anonymous inner class, which we will see quite often throughout this course, you must declare anything that it hoists as final. And if you're unfamiliar with the term hoist, hoist simply says that we are hoisting this variable into a different scope, essentially, because this scope is, it is underneath, lexically, this other scope, but in reality, this code is not going to be invoked sequentially, as the rest of the method is. Instead, it's going to be invoked whenever the button is clicked, outside and once this method is done running. Anyway, just a quick note, you'll always have to do that when you do stuff with things. Now again, why don't I have to do that with click count? Well, that's because click count is a private field. It isn't a local variable. But yeah, really, that's about it. I guess the only other way that I could see handling an on-click event would be you could have this code, for example. Well, no, you couldn't because we're hoisting text view. But if it wasn't hoisting text view, we could instead assign this to a local field and then reuse it, or a local variable and reuse it for multiple buttons. Like, for example, if we wanted to do view.onClickListener, listener equals, we could do that, and then we can assign it like that. That way you'll be able to assign the same instantiation of this anonymous inner class to multiple click handlers. Alright, well, that's really all I wanted to talk about in this video. There's only one more thing, just one more side note, and you'll see me do this a lot in the series, and I don't want to have to re-explain it, because I might as well explain it here. Set onClickListener comes from the view class. As you see, this massive, massive, massive class. I can't even find the header of this class. Anyway, this is the view class. That is where setOnClickListener comes from. Why is that important? It's important for a non-obvious reason, and for a reason of flexibility. When you have a button, what are the chances that you are going to do something with a button that doesn't, or beyond setting the on-click listener? Not a whole lot. In fact, that's typically what you're going to be only using a button for when you reference it from code. Because for that reason, you shouldn't use, in those cases, the button class. Instead, I would prefer, in my opinion, I prefer just simply doing view and removing the cast. So say view button equals find view by ID, and then say button.setOnClickListener. Now, why is this important? Well, what if down the road on our layout we have this button, but then we decide that we want it to be now an image button, for example, a different view that acts as a button but is a different class? Well, then we would have to go into our activity and refactor all the references to it, because image button does not inherit from button. So, to make the code a little bit more flexible, if all we need to do with a button is set the on-click listener, I'll refer to it as a view. And then in the future, if I need to refer to it as a button, I can refactor that. But that'll allow me to, inside my layouts, decide if I want to have a button, an image button, a text view, an anything view to be the clickable entity without having to modify any of my activity code. Anyway, I think that does hopefully actually wrap everything up. I don't think I have anything else to say about buttons or inner classes. So, we'll see you guys in the next video.